morning. In this content, we are going to discuss the kinds of the transformation, elliptical, hyperbolic and parabolic, right? We have to recall few results first that are very helpful in understanding the transformations. First, for one finite fixed point alpha and other fixed point infinity, the transformation is w minus alpha equal to lambda times z minus alpha, where lambda is a over d. Second, if infinity is the only fixed point, then transformation is w equal to z plus b over d. That is the translation transformation, right? I have also discussed this transformation in the previous content. You can also check from there. Third, for two finite fixed points alpha and beta, the transformation used is w minus alpha over w minus beta equal to lambda times z minus alpha over z minus beta. This transformation is also called normal form of transformation, the bilinear transformation, right? Where lambda is equal to d plus beta c over d plus alpha c. For the quadratic equation that is in z, which is cz square plus d minus a into z minus b is equal to 0. Now how this quadratic equation is obtained? From the transformation w equal to az plus b over cz plus d. Whenever we talk about the fixed points, we always take w to be equal to z, and when you put w equal to z over here, just cross multiply, you will get the quadratic equation in z as this. Right? Okay. Now let's start with the elliptical transformation. So for the elliptical transformation, for w is equal to the original transformation az plus b over cz plus d, please mark this as 1. We have quadratic equation in z as, yes, cz square plus d minus a into z minus b is equal to 0. So for the transformations, we are going to discuss two cases about the fixed points. The first case, when the two fixed points are finite, and in the second case, when one fixed point is finite and other is at infinity. So for the first case, let's take the first case as for two finite and distinct fixed points. Let's say alpha and beta. And the condition used is, yes, in the previous contents, I have also discussed all the conditions about the fixed points. Please check from there. Okay. So for the finite and distinct fixed points, the condition is C is always non-zero and discriminant of this quadratic equation is also non-zero, where this discriminant is equal to a minus d whole square plus 4bc. So this is non-zero. Now what transformation is to be used for the two fixed points? Let's recall again. Yes, for the two fixed points, we are going to use this transformation, right? So the transformation can be put in the form, yes, for the fixed points alpha and beta, w minus alpha over w minus beta is equal to lambda times z minus alpha over z minus beta. Please mark this as 2, where this lambda is equal to d plus c beta over d plus c alpha, right? This is finite constant. Now when this mod lambda is equal to 1, then the transformation is elliptic, right? So from 2 we get, let's take mod on both the sides, we get mod of w minus alpha over w minus beta is equal to mod of lambda into mod of z minus alpha over z minus beta. Now here mod of lambda should be taken to be equal to 1 for the elliptical transformation. So we get mod of w minus alpha over w minus beta is equal to mod of z minus alpha over z minus beta, right? So first case is discussed for the two finite fixed points. Second case, if one fixed point is finite and second fixed point is at infinity. Let's recall again. So for one finite fixed point alpha and other fixed point at infinity, we are going to use the transformation as w minus alpha equal to lambda times z minus alpha, where lambda is a over d. So let's use this transformation. First, let's write the condition. The condition is c equal to 0 and the discriminant is always non-zero. So in both the cases, discriminant should be taken non-zero. And for the finite fixed point, we take c to be non-zero. But one of the point is if at infinity, we take c to be equal to 0 always. So the transformation is, yes, w minus alpha equal to lambda times z minus alpha, where alpha is your finite fixed point. Only one, right? Where lambda is equal to a over d. And for the elliptical transformation, we take mod of lambda to be equal to 1. So let's take mod on both the sides. So for mod lambda equal to 1 implies mod of a over d equal to 1. So mod of a over d is equal to 1. That is mod of a over mod of d equal to 1, which implies mod a is equal to mod d. Then the transformation is elliptical, right? So this is all about elliptical transformation. Next is hyperbolic transformation. For the hyperbolic transformation, first case for the two fixed points, that is alpha and beta. So for the two fixed points, the condition is c is non-zero and discriminant is also non-zero. And here let lambda be real and positive. In that case, lambda is finite constant. So that argument of lambda is equal to 0. So in case of hyperbolic transformation, we take argument of lambda to be equal to 0. Now, for the two fixed points, what kind of transformation we use always? Yes, I have written over here w minus alpha over w minus beta equal to lambda times z minus alpha over z minus beta. We use this kind of transformation for the two finite fixed points. So now because for hyperbolic transformation we use argument of lambda to be equal to 0, let's take argument on both the sides of this equation too. So taking argument on both the sides, we get argument of w minus alpha over w minus beta equal to argument of lambda plus argument of z minus alpha over z minus beta. So this implies argument of w minus alpha over w minus beta is equal to, yes, this is 0. Yes, this is 0. 0 plus argument of z minus alpha over z minus beta. This implies argument of w minus alpha over w minus beta is equal to argument of z minus alpha over z minus beta. This is the condition when we are having the two finite fixed points in hyperbolic transformation, right? Okay, now the second case, when one point is finite and second point is infinity. In that case, we are going to use the transformation as w minus alpha equal to lambda times z minus alpha, where lambda is a over d. And the condition is always c equal to 0 and discriminant is always non-zero. And because for hyperbolic transformation, argument of lambda is equal to 0, so from 3, let's take argument on the value of lambda on both the sides. So taking argument on both the sides, we get argument of lambda equal to argument of a over d. This implies argument of lambda is equal to argument of a minus argument of d. And because argument of lambda is 0, let's take this to be equal to 0. And taking argument of d to the other side, we get argument of A is equal to argument of D, right? Because argument of lambda is equal to 0 for hyperbolic transformation, right? Okay, so this is about the hyperbolic transformation. Now the last one is parabolic transformation. In case of parabolic transformation, we are having the fixed point to be at infinity. Let's recall again for parabolic transformation. So for the parabolic transformation is if infinity is the only fixed point. So we are going to use this kind of transformation, that is W is equal to Z plus B over D. And in that case, here discriminant is 0. So the transformation is W equal to Z plus B over D. This is called parabolic transformation. And delta equal to 0 means what is delta? Delta is A minus D whole square plus 4BC is equal to 0. And in the first case, the condition is let C equal to 0. So when C equal to 0, we put C equal to 0 over here. Then we get A minus D whole square to be equal to 0. That is A is equal to D. So in this case, we also having A is equal to D, which is non-zero. And the linear transformation is of the form, yes, W is equal to, what is the linear transformation? That is the original one, AZ plus B over CZ plus D. This will become, okay, putting A equal to D. First, let's put C equal to 0 over here. AZ plus B over D. And then putting A equal to D also. So we get, if I split this as A over DZ plus B over D. And for A is equal to D, I'm having value as, it gets cancelled out. So this is Z plus B over D. That is the parabolic transformation. Right? Right? So it reduces to the parabolic transformation. Now, if B over D is 0, then we get W is equal to Z. So if B over D is equal to 0, we get, putting B over D as 0, we get W is equal to Z. This is your W. So we get W is equal to Z. Then the transformation reduces to, this is nothing but identity transformation, right? So the transformation reduces to identity transformation, which means every point is a fixed point because all the points in the Z plane are equal to all the points in the W plane, right? Which means every point is a fixed point. If W equal to Z, then this means every point is a fixed point, right? Okay. If B over D is non-zero, then transformation reduces to simple translation, that is W is equal to Z plus B over D. This is your simple translation transformation, right? So in this case, the only fixed point is at infinity. Now in the second case, let's take the case for only one finite fixed point. The fixed point, but that is finite. In that case, the condition is discriminant is 0 but C is non-zero, right? For fixed point at infinity, we have taken C to be 0 and discriminant to be equal to 0. Both are zeros. But if there is only one finite fixed point, then discriminant is 0 but C is non-zero. So let W is equal to AZ plus B over CZ plus D. Then the quadratic equation in Z, if you put W equal to Z over here for the fixed point, you get the quadratic equation in Z as CZ square plus D minus A into Z minus B equal to 0. Now this equation has only one root. How? Let's take the roots of this. Yes, for the quadratic equation, we get the roots as Z equal to, yes, minus B, that is A minus D, plus minus square root of B square minus 4AC, that is 4BC, divided by 2C. Now here, this is your discriminant, right? This is your discriminant, that is delta. In this case, delta is taken to be as 0. So this is 0, which means I get Z to be equal to A minus D over 2C. The only finite fixed point is named as Z equal to A minus D over 2C, right? And let's name this fixed point to be as alpha, right? So this implies alpha is equal to A minus D over 2C. Now the root of the equation, that is alpha is equal to A minus D over 2C, is the only fixed point, finite fixed point of the parabolic transformation. Now since Z equal to infinity is mapped into W equal to, yes, A over C. See, if you from here just take Z common, so you get A plus B over Z over C plus D over Z. If Z is tending to infinity, then this W will tend to A over C, yes, right? Okay. So since Z equal to infinity is mapped or transformed into W equal to A over C, so that infinity is not a fixed point, because the only fixed point is A minus D over 2C. So every bilinear, please note over here, every bilinear transformation which has only one fixed point alpha can be put in the form, yes, this is your fixed point alpha. So in this case of transformation, when we are having only one fixed point alpha, the transformation will take form as 1 over W minus alpha equal to 1 over Z minus alpha plus lambda. Hence the transformation becomes 1 over W minus alpha equal to 1 over Z minus alpha plus lambda, where lambda is 2C over A plus D. Please check from the previous notes. This kind of transformation is also discussed over there. Let's take this 1 over W minus alpha as W dash and this 1 over Z minus alpha as Z dash. So taking W dash as 1 over W minus alpha and Z dash as 1 over Z minus alpha. So from 1 what we get? W dash is equal to Z dash plus lambda, which is a parallel displacement of Z dash plane, right? So let's revise few remarks. Number 1, for mod lambda equal to 1, the transformation is elliptic. For lambda to be real and positive with argument lambda equal to 0, the transformation is hyperbolic. If lambda is neither real nor mod lambda equal to 1, the transformation is termed as loxodromic. So in this case, the value of lambda is imaginary. And then fourth, if Z equal to alpha is the only fixed point where the discriminant equal to 0 for the quadratic equation in Z, the transformation is parabolic. Here the number of fixed point is only 1, right? Okay, so this is all about the kinds of the transformations. In the next content, we are going to study the examples based on the fixed points. Alright, thank you. Stay blessed.